Hi everyone, in today's lesson we're going to talk about special right triangles and how they relate to finding exact values. We have to recall that a 30, 60, 90 right triangle looks something like this, where there's a 30 degrees, a 60 degrees, and a 90. And a 45, 45, 90 right triangle looks like this, 45, 45, and 90. And assuming that we're in a unit circle, this is what the sides would look like in a 30, 60, and 90. There would be a 2, a 1, and a radical 3. A 1, and a radical 2. So no matter where you put the 30, no matter where you put the 60, always across from the 30 is 1, right? So across from the 30 is a 1. Always across from the 60 is radical 3, and always across from the 90 is 2. Okay? And in each 45, across from each 45 is a 1, always, and across from the 90 is a radical 2. Okay, so let's figure out what all of these values will be using these special right triangles. So let's write down SOHCAHTOA. We may need that. So sine of 30. Sine is opposite 1 over hypotenuse. So sine of 30 is 1/2. All right, let's do cosine of 30. Here's 30 cosine, adjacent over hypotenuse. So rad 3 over 2. And then tangent of 30, TOA, opposite over adjacent. So 1 over rad 3. But that should ring a bell that we're not allowed to have radicals in the denominator. So we have to multiply the top and bottom by radical 3. So it would be rad 3 over 3 after I simplify it. All right, now let's move on to 60. So we've got sine, opposite over hypotenuse. So rad 3 over 2. All right, now cosine of 60. Here's 60, here's adjacent, here's hypotenuse, so 1/2. Tangent of 60 is TOA, opposite over adjacent, so rad 3 over 1, which is just rad 3. And last but not least is the 45-degree angle. So it doesn't matter which angle you choose, so I don't know, I'll pick here. Sine of 45, opposite over hypotenuse. So 1 over rad 2. Again, realizing we can't have a radical in the denominator. So it's rad 2 over 2. Cosine of 45, again, it won't matter if I start here or here. So cosine is 1 over rad 2 again, adjacent over hypotenuse, which we know will eventually reduce to rad 2 over 2. And tangent of 45 is TOA, opposite over adjacent. So 1 over 1, which is 1. Now, this was really the one way to memorize these exact values is if you know these charts, you could pull out one of these off the top of your head by just knowing opposite, adjacent, hypotenuse, whatever. Okay, but I think the easier way for some is an exact value chart. Okay, and this is how it works. The theta always goes here, so let's go ahead and draw that with me. Sine of theta goes here, cos theta, tan theta. And the angles that we care about are 30, 45, and 60. And they have to go in that order, increasing order. So 30, 45, and 60. So if you memorize the setup and then memorize this down here, you're good to go. So how does it work? It goes 1, 2, 3, 3, 2, 1. So let's write it in. 1, 2, 3, 3, 2, 1. Now everything you just wrote, all over 2. So everything gets over 2. Okay. Now square root everything in the top. I know it doesn't say top, but square root everything except 1. So square root everything in the top except 1, because the square root of 1 is just 1. So we get a radical 3, a radical 2, a radical 2, radical 3. And the last row is everything to do with the 3's. So we keep with the fraction. So rad 3 over 3, 1, and rad 3. So if you memorize this chart, which I know it seems a little overwhelming right now, it's actually not that bad once you do repetition with it. I know that cosine of 60 is a 1/2. Well, let's see. Cosine 60 is a 1/2. And I know cosine of 45 is going to be rad 2 over 2. Cosine of 45, rad 2 over 2. Even tangent of 30, rad 3 over 3. Okay? So it helps. Let's make the chart one more time. All right. So we've got theta here. We've got sine theta, cos theta, tangent theta. Angles go in order, 30, 45, and 60. So let's recall how to do it. 1, 2, 3, 3, 2, 1, all over 2. Everything on top gets a radical, except for the 1's. Now we stick with the bottom of tangent is all 3's. Rad 3 over 3, 1, and rad 3. Now why am I talking about this? Well, because the directions will ask you to find the exact value of each function. So we need the exact value chart. So we're going to use quarters are for sodas. All right, so let's use what we did the other day. Quarters are for sodas. Okay, so where's 240? All right, let's draw a quick sketch of this guy. 240, I think's in here. Yep. Quadrant 3. How do I find a reference angle in quadrant 3? We take the angle 240 minus 180, and we get 60. The function we're dealing with is sine, and all students take, right, I'll even draw it in, A, S, T, C. Tangent is the only thing that's positive, so sine will be negative. So we read it from the bottom to the top, as always. So negative sine of 60. This here is rewriting it as a positive acute. That's what we did the other day. So if I want to take it one step further, I'm going to ask you to find an exact value. And I can't make it an exact value unless this angle down here comes out to 30, 45, or 60. So sine of 60, we look, sine of 60 is rad 3 over 2. So the answer is negative rad 3 over 2. That answer here is the exact value. I can't ask you to find an exact value unless the angle, again, comes out to 30, 45, or 60. So this is really just one step further from the other day, okay, from positive acute. So now we're going to find an exact value. All right, so let's do cosine of 300. Let's draw a picture. Quadrant 4, so Q, R, F, S. I'm in quadrant 4. To find a reference angle in quadrant 4, I take 360 minus the angle, and that gives me 60. The function I'm dealing with this time is cosine. Now let's talk about all students taking calc. So in quadrant 4, the only thing that's positive is cosine, so this would be a plus. So the way we would write it from the bottom up would be cosine of 60. Now, okay, cosine of 60 is 1/2. That is my exact value, and this is my positive acute. Now you could check into the calculator if you'd like. You could check to see that sine of 240 is the same decimal equivalent to this. You could check that cosine of 300 is the same decimal equivalent to 1/2. All right, I'm going to try one more with you, which is tangent of 495. So just like we did with positive acute, we got to make it coterminal. So we're going to take 495 and we're going to subtract 360, which is 135. So we're going to do tangent of 135. So Q, R, F, S. I am in quadrant. 135 is quadrant 2. To find a reference angle in quadrant 2, it's 180 minus 135, which gives you 45. The function I'm dealing with is tangent. And in quadrant 2, it looks like tangent is negative. So, negative tan of 45. Now we look at the chart. Negative tangent of 45 is going to be negative 1. That's it. Final answer. Okay, now what I'd like to do is explore these next three. Let's go with the first one. It says cotangent of 7 pi over 6. So just like we did with positive acute, we have to make this a degree first. So let's do that. We multiply by 180 over pi. The pi's will cancel. Now multiply 7 times 180 and divide that by 6. So I get 1,260, which gives me 210. So I'm going to do the same thing now, but with cotangent of 210. So we've got Q, R, F, S. 210 is an angle in quadrant 3. The reference angle is 210 minus 180, which is 30. The function I'm dealing with is cotangent, and all students take, so let's write that in, A, S, T, C. So tangent is positive. That also means cotangent's positive, so plus. So we read it from the bottom up, and our answer is positive cotangent of 30. Now this chart up here does not have cotangent, but it has tangent. So if I know tangent of 30, how could I figure out cotangent of 30? Well, you just have to flip it, because they're reciprocals. So if tangent of 30 is rad 3 over 3, then cotangent of 30 is 3 over rad 3. You just have to flip it, okay? But we can't have a radical in the bottom of a fraction, so we have to rationalize it. So this becomes 3 rad 3 over 3. These cancel. You just get rad 3. Okay, so why don't you try for homework? I'll label these homework. I'm checking to see that you did it. Please try these two all by yourselves, and we'll start there tomorrow in class, but someone has to remind me to do that. All right, so let's just summarize everything that we did. So to find the exact value of trig function, we used quarters are for sodas, and then the exact value chart. And remember, if it's a reciprocal trig function, don't forget to flip your answer. Okay? So please try this one, and we'll see you in class tomorrow. Have a good night.